Hello guys, in this video I will show you how to express absolute value functions as piecewise functions. First of all, we need to remember what is absolute value. Remember, absolute value, we express it like this with bars, and the absolute value of a positive number, in this case 5, is the same number. The same, that is for positive number. And what happened with negative numbers, for example, the absolute value of negative 5, it will be still 5. So it is the opposite. So as you can see, for the negative values, what we are doing, we are multiplying times -1. So we can express this in general. Let's write it as a function, f of x equals the absolute value of x. That means, and we can also use the notation of piecewise, that the absolute value of x is x when this part that is inside the absolute value bars is positive. So when x is positive, greater or equal to 0, that means positive. Well, the 0 in the case, you can include the 0 in the positive or in the negative, anyway it will be 0. Then it is going to be negative x, so we are multiplying times -1 when the x value is negative. So let's write it, that's for values of x when this part that is inside is negative. How do we express it? Like this, when x is less or equal than 0. So this is one way we can express as a piecewise function the absolute value of x. Let's try with this exercise. F of x equals the absolute value of x plus 3. Again, we can write it as f of x equals, and we use this notation of piecewise functions, and we say is the same when this part that is inside the absolute value bars, when x plus 3 is positive. Remember, we can include the 0 either here or in the negative side, and it will be the opposite. The opposite is multiplying times -1 when this part inside, that in this case is x plus 3, is less than 0, when it's negative. So when it's negative, then we write the opposite. Now we can simplify it. How? By solving the inequalities. Here we have an inequality. How do we solve this inequality? We can put the 3 as -3 over here, and this remains the same. We cannot simplify it, but we can simplify the inequality, or we can solve for x. So in this case, for values of x that are less than -3. And here we have the expression for this first exercise. Okay, now let's try a harder exercise, that is the one below. For the second exercise, we have two parts. The first part is this part over here that I'm going to call it m of x, and this part is just what we have solved over here in the first exercise. And we have another part that is this part. I will call it n of x. So let's solve n of x. N of x, that is the second part, is equals to the same value, that is x minus 1, when x minus 1 is positive. And it will be the opposite, minus x plus 1 when x minus 1 is negative. I will simplify it down here using the notation we just have learned, or the way we have just learned to simplify it. We cannot simplify this part. However, we can simplify the intervals. So is for values of x that are greater or equal than 1, and for values of x that are less than 1. I am just simplifying these inequalities over here. Now we have the two expressions, the expression of m and n. So that means that for this second exercise we have actually 3 intervals. What happens with numbers less than -3, what happens with numbers between -3 and 1, and what happened with numbers more than 1. How do I know those numbers? It's easy. I am just looking at the intervals. The interval over here that includes a -3, also here, you can see it. And I am also using the interval of the second part that includes the 1. So there are different behaviors for each of the intervals. Okay, now we have to write the function f of x using the corresponding behavior. So I will write f of x. I know it will have some behavior for values of x that are less than -3. So what values are we going to use here? We're going to use, let me mark it with green, this first part. For the first part, we're going to use this because we know that values -3 will be less than 1. And this because we know that values of -3 will be less than -3 actually. So we are going to combine those functions. So it will be minus x minus 3 minus x plus 1. I am combining just the function m and n. Then we know we have another interval. The other interval is between -3 and 1. This will be this interval over here. So which functions are we going to use? For the first one, m of x, we're going to use this function because we are now using numbers that are more than -3. You see, this is the rule that I am following. And in the second part, we are still using this part. Why? Because we are using numbers that are less than 1. We are using this interval that is between -3 and 1. So I am going to write those functions. The first one, it will be x plus 3, x plus 3. And for the second one, minus x plus 1. Finally, we have a third interval that are the values. And let me write it with this color. That are values that are more than 1. So we are going to use this function because it's for values that are more than -3, and more than 1 means also more than -3. And this other function because we are using values that are more or equal to 1. So let's write that function over here. And well, first write that we are using values that are more or equal to -1. So now that we have those values, let's write the blue ones. For the first one is x plus 3, and for the second one is x minus 1. Okay, then we only need to simplify it. To simplify it, we have to simplify. Minus x is minus 2x, and minus 3 plus 1 is minus 2. And that's for x less than -3. Then the second part is x minus x is 0x, and 3 plus 1 is 4. So it's 4 for -3, 2, 1. Finally, x plus x is 2x, and 3 minus 1 is 2. And that's for values that are greater than -1. Finally, we have a third exercise that in this case we're using a parabola. So we're going to solve it the same. We're going to write f of x is the piecewise function that is the same, x squared minus 9, when x squared, that minus 9, that is the inside part, is greater or equal to 0, when it's positive. And it's the opposite, minus x squared plus 9, when the inside part, that is x squared minus 9, is negative or less than 0. But in this case, it will be a little bit hard to solve these inequalities. To simplify it, I'm going to solve the first one. So I write x squared minus 9 greater or equal to 0. That means that x squared has to be greater or equal to 9. So we have two possible solutions for these ones. The first one, if we know that we want a number that is greater or equal to 9, we can say, taking the square root, that x has to be greater than 3. Why? Because numbers like 4, 5, 6, 7 squared will be more or equal to 9. But what happened, remember, there are two square roots. What happened with the negative square root? That the negative square root in this case is negative 3. We need values of x that are actually less than negative 3. Why? Because more negative values, such as, I don't know, negative 4, negative 5, negative 6, will produce numbers squared that are that are more or equal than 9. That's why we have those possible solutions. In the case of the second one, I'm going to solve it over here. We write the same. X squared minus 9 is less than 0, so x squared is less than 9. And again, we have two possible solutions. Remember, we can find the square root, and it will be 3 and negative 3. Those are the two square roots. What happened with the positive square root? We need values of x that the squared is less than 9. So in this case, it will be less than 3. But also, we have to find values of x which the squared is less than 9. So it has to be more than negative 3. For example, negative 1. So as you can see, here we have an interval between those two numbers. We have values of x that are more than negative 3, but less than 3. So we are producing this interval. Now we can use the notation and find the final notation for this piecewise function. It will be x squared minus 9 for values of x that are less than negative 3. We are using in this case this one. Then we are going to use the second interval, that is this one. And for this interval, remember, it's the inverse, minus x squared plus 9 for values of x that are between negative 3 and 3. And finally, we're using this for values of x that are more than 3. And I'm going to write it here. Is x squared minus 9. Why? Because we are using this one, and this belongs to this one over here. Sorry, it belongs to this one. I was making a mistake. It belongs to this one. That is that one over here. So that's why I'm writing the positive. And for values of x that are more than 3. And in those two, the red one and the green one, I forgot to write the equal, right? So I write it here in order to include the 0 points.